In lesson 4.7, we'll be using completing the square to solve quadratics. But before we begin that process, on this slide we're going to look at some building blocks that we'll need to do that. We can solve x squared plus 6x plus 9 equals 36 by finding the square roots. So the first thing we need to do is factor the left side. So I'm going to use x plus 3 squared equals 36 because I saw that we had a perfect square trinomial. The next step is to find the square root of each side. X plus 3 equals plus or minus the square root of 36, which is really x plus 3 equals plus or minus 6. Now we'll solve for x by subtracting 3 from both sides. X equals negative 3 plus or minus 6. So x equals negative 3 plus 6, which equals 3. X equals negative 3 minus 6, which equals negative 9. If you are asked to find the value of c that makes the expression a perfect square trinomial, the first step is to take half of the x coefficient. So half of 22, and then we're going to square it and replace c with that value. So x squared plus 22x, half of 22 is 11, and we square it. So we replace the c with that value. And then we just simplify. X squared plus 22x plus 121. All right, we have another one. X squared minus 9x plus c. So again, we're going to take half of the x coefficient, square it, and replace c with that value. So x squared minus 9x plus half of 9, so I'm just going to keep it as a fraction, 1/2 times negative 9, so negative 9 halves, squared. And then if I were to multiply it out, we end up with negative 9 times negative 9 is 81, and 2 times 2 is 4. We needed to remember to square the numerator and the denominator. All right, so now we're going to solve by completing the square. And there are a couple of things we need to check before we begin. We need to make sure that the constant is on the side by itself. So I'm going to move over by adding 24 to both sides. So the constant is on the right-hand side all by itself. The second thing we need to check is that the coefficient of the squared term must be divided out so that it's equal to 1. And you can see that it already is, so we don't have to do anything with that. Now we're going to complete the square. All right, so we're going to take half of the coefficient of the x term, and we square that. And if I perform that on the left-hand side, I must carry it over to the right-hand side. Next, we're going to factor the left side and simplify the right. X plus 5 squared. Basically, we just take the x and the 5. That's why I did not multiply 5 times 5 and get 25, so I could just pull it down. And then we say 24 plus 25 is 49. The next step is to take the square root of both sides. So x plus 5 equals plus or minus 7, and now we just continue to solve. So if I subtract 5 from both sides, x equals negative 5 plus or minus 7. So x is equal to 2 and negative 12. At this point, you should pause the video and write the steps in your notebook. All All right, here's a second example. So remember, there are two things we need to do before we start completing the square. We need to make sure that our leading coefficient is 1 and that our constant is on the right-hand side by itself. So the first thing we'll do is to divide every term by 2. So x squared plus 4x plus 7 equals 0. Next, we're going to subtract 7 from both sides. X squared plus 4x, I'm going to leave a space, equals -7. Then we take half of 4 and we square it. And if I perform that on the left, we need to do the same thing to the right. Next, we're going to factor x plus 2 squared and then simplify the right-hand side. Now we need to find the square root of both sides. So we end up with x plus 2 equals plus or minus the square root of -3. Recall what we learned about imaginary numbers because we have that negative under the radical. So we can actually, after we subtract 2 from both sides, so x equals -2 plus or minus, that -1 is actually an I. So x equals -2 plus or minus I square root 3. We could leave it like that, or we could write -2 plus I square root 3, -2 minus I square root 3. Next, we'll write the quadratic function in vertex form. All right, our final example. So vertex form. Vertex form, recall, is y equals a times the quantity x minus h squared plus k, where hk is actually equal to the vertex. All right, with that information, we're going to go ahead and begin solving. All right, so I rewrote the quadratic function, but I left some spaces where we're going to complete the square. So remember, we take half of the x coefficient, so that's going to be -4, and we're going to square it. So I'll put it here. And then we do it to the left-hand side as well. Then we're going to simplify and factor, so we end up with y plus 16 equals x minus 4 squared plus 17. And now if we subtract 16 from both sides, y equals x minus 4 squared plus 1. Our vertex is HK. So in this case, our vertex will be 4, 1.